Hi guys, let's take a look at this video together.
Engineer, see this place. This guy loop. This is the out. This is the men's out. You understand? So this is the AC in. He looped uh the the neutral, of the AC in, and the neutral of the men's out together.
So the question reads, please, the neutral output loop to mains neutral AC input is causing backfeeding. What can I do to correct these issues, my able engineer? It's a hybrid inverter. Please, this video is the kind of video where I need feedbacks from people as well. Please, if you think you know the reason why this is happening, please drop it in the comment section. So let's go ahead to find out what backfeed really means. Now, backfeed happens when electricity flows in the wrong direction. That is, from your inverter or load side back into the grid or another inverter source when it shouldn't. The main reason why backfeed occurs in hybrid inverter is, one, when you use a shared neutral, that means common wire. If you use one neutral for both input and output, it returns current from inverter load can flow back into NEPA. That is one of the reasons why backfeed happens. So let's check some comments from members of our Facebook group. So now, Nandi Christian Fabs said something. He said, it's a poor job done by a lazy and untrained fellow. First, not all inverter that is designed for common neutral, right? If any inverter is designed for common neutral, it will be indicated on the body, like most Indian inverter, mostly transformer based. Well, you may be right, but I don't think I've seen where common neutral is indicated on the body of the inverter. It might exist, right, but I've not seen any. Usually they put these things in the manual, or you might have to use your multimeter to test that yourself. Now, second, when you do common neutral, you put the inverter at the risk of burning from current feedback from utility or gen. That was the same thing ChatGPT said. Third, the inverter will be prone to damage from lightning because neutral carries lightning volt faster. Now, if this is the case, then it will affect both the input and the output, because anything that passes through the input goes to the output. And if the thunder is striking, it comes in through the input, right? As it comes in through the input, it goes out through the output if your system is not properly at. So definitely it will still affect this. Now, number 4, the wire is also at risk because when you do common neutral, the neutral line is now carrying double of the current it is supposed to carry. Now, this is not true. This is not true at all, right? So Emmanuel Wike said, use multimeter and check continuity in input and output neutral. If there's continuity, then the connection is okay because the previous installer is saving cable. But if there is not, it means the inverter doesn't support a central neutral. Just like I said earlier, most times when I go for installations like that and it's an inverter I've not used before, I test the neutral first. On your multimeter, just set it to continuity, put both your negative and positive cable to where the two neutral is and test. If it makes that beep sound, it means it is interconnected, so you can use a cable. If it is not interconnected, you have to run the cable separately. Or sometimes when I don't use the same neutral is when we have 3 load source. We have the gen, we have the NEPA, and also we have the inverter. Those are 3 load sources. You cannot share neutral for those kind of sources, so you have to run separate neutrals, right? So Umaru Yusuf also said, how some of you came up with this idea of tying mains neutral line with inverter neutral line is what I can't comprehend. Avoid tying neutral lines of different energy sources together. This is a very good advice. Although we've always been hearing it that it's not good to do this, it's not good to do this. But then when you do it, it works. It saves time, it saves energy. And then you just use it. Because I could remember the first time I did that, I tried it in my house first. I used it for almost 5 months. There was no issue. Before I started using it for some of my clients, and then since then I've not had any issues or complaints about it. So also, Onaha Brendan Tochuku said, I don't know for you all, but I have never been a fan of common neutral idea. What if there's a fault in your AC input line? It will end up sending damaging feedback to your inverter. Now, this is a very good observation, but here's the problem. If there's a fault in your AC input line, right, as long as that AC input line enters the inverter, it will definitely affect the output line. Because except maybe there's a breaker to break it from entering the output line, because definitely, because it's a hybrid inverter, it does bypass, meaning anything entering your AC is still indicating in your output. So if any issue comes, this thing will definitely happen, right? So let's also check ChatGPT one more time. He said, so I said, what if the only source is NEPA? So it answered, it says, you may use one neutral if, one, the inverter manual states input and output neutral are common, right? Two, if there is no neutral switch relay inside the inverter. Three, if you are not using a generator. Now I understand the generator part, because sometimes our generator carries two live. Do you understand? So it is very, very dangerous. Now, three, if there is no separate earthing system. Or four, if the neutral wire is the same size as the line. Now you can see below here, it said most popular hybrid inverters like Felicity, Growatt, Most, and Deye do not have common neutral. Okay, sorry, do have common neutral, but you must confirm in the manual. Now, so I asked a summary of the whole thing, and then he gave me, said yes, it can work, but only if your hybrid inverter has a common neutral internally. Now I've asked some engineer in the past this question, and then most of them confirm yes, it is the same cable that runs your both the input and output neutral to the terminal of the board. So guys, please drop your feedback. Let's know what you think about this. Thank you.